Welcome to the deep dive. Ever looked at a steel part, maybe a bracket, and seen something like 16 gauge
Hmm.
and wondered, wait, is that stronger than, say, 20 gauge? Or maybe you've just been confused why a higher number actually means thinner steel.
It trips a lot of people up.
Yeah, exactly. Well, today we're going to unpack that. We're digging into the hidden logic behind steel thickness, something the pros really rely on.
Absolutely.
Our mission today is pretty straightforward. Demystify steel gauge, clear up that confusion, and really help you figure out how to choose the right thickness for whatever you're working on. We're using insights from a guide by Dundee Manufacturing Company to help us out.
Precisely. And understanding gauge, it's kind of the secret sauce, isn't it?
Yeah.
For balancing strength, weight, and crucially, the cost in pretty much any steel application.
The cost, right? Didn't even think of that initially.
Oh, yeah. It can make a big difference between a project that works perfectly and one that's maybe overbuilt and expensive, or
This
worse,
fails.
or fails. Under-engineered. Definitely want to avoid that.
Okay, let's get right into that core puzzle then. What is steel gauge, just fundamentally?
Well, at its simplest, gauge is just a unit of measurement. It tells you the thickness of a sheet of steel.
Okay, simple enough.
But here's the twist. The thing everyone finds counterintuitive. The higher the gauge number goes,
Huh?
the thinner the actual steel is.
Right. See, that's it. So 16 gauge is actually thicker than 20 gauge.
Exactly. Noticeably thicker. It's definitely something you have to consciously flip in your head when you first learn it.
It really does mess with your intuition, doesn't it? My brain just expects bigger number, bigger thing, bigger thickness.
Yep, common reaction.
Is there, like, a historical reason for why it's set up this way? Or is it just one of those legacy things we're stuck with?
It's mostly a legacy thing. It comes from older manufacturing methods.
Ah,
Yeah, the gauge number originally related somehow to the number of times the metal was drawn or passed through rollers to get to that thickness. More passes, thinner metal, higher number, something like that.
okay, that helps a bit.
But maybe a better way to picture it is the range. Think about, say, a 10-gauge piece that's quite thick, over 1/8 of an inch, used for really heavy-duty stuff.
Right, structural.
Yeah. Now compare that to something like 26-gauge. Super thin. Barely thicker than cardstock, really.
Wow, big difference.
Huge difference. And that really shows you that inverse relationship. Higher number, much, much thinner.
Got it.
Now, one small note if you're working with galvanized steel or stainless steel, the actual decimal thickness for a given gauge number might be slightly different than plain carbon steel. Just something to be aware of.
Okay, good tip. So we have these numbers, these gauge numbers, and they correspond to decimal thicknesses, like zero point 0 whatever inches. But how does that translate for me, when I'm actually working on something? How do I use this to pick the right steel?
Right, this is where it gets practical, actionable. The easiest way to think about it really is based on the duty level your project needs.
Duty level. Okay, I like
Yeah, it simplifies things.
Yeah.
You can basically break it down into 3 main categories.
Okay.
Okay. First, you've got heavy duty. For this, you're usually looking at steel in the 10 to 14 gauge range.
the thicker stuff, lower numbers.
Exactly. This is for robust applications. Things where you need maximum strength, maximum rigidity. Think structural brackets holding serious weight, maybe critical wall ties in construction, industrial hangers.
Stuff that absolutely cannot bend or fail.
Precisely. It's all about load-bearing capacity and stability.
Okay, heavy duty, 10 to 14 gauge. What's next?
Next up is medium duty. This generally falls between 16 gauge and 20 gauge.
Ah, okay, the middle ground.
Right. And this is often the sweet spot. You get a good balance of strength, but still maybe a little bit of flexibility depending on the exact gauge and how it's formed.
What kind of things fall in here?
Oh, lots of common stuff.
Yeah.
Pipe straps for plumbing, supports for electrical boxes, mounting components for HVAC systems. A lot of the hardware you'd buy, like thinking of Dundee's products, their metal plumber's tape or standard pipe straps,
Yeah.
they'd likely be engineered from steel in this medium range.
Okay, that makes sense. Common hardware stuff. 16 to 20 gauge. And the last one.
That would be light duty. Here you're talking about 22 gauge up to 26 gauge.
So the higher numbers, the thinnest steel.
Yep. For these applications, you need less brute strength, but you might want more malleability. Maybe it needs to be lightweight.
Like what?
Think protective covers for equipment, maybe some types of very flexible strapping, or even decorative metalwork where you actually want to bend and shape it easily.
Gotcha. Covers, decorations, things where formability is key.
Exactly. Less about holding weight, more about shaping or covering.
That's actually a really helpful way to frame it. Heavy, medium, light duty, instead of just memorizing numbers.
Right. It gives you a practical handle on it.
So for you, listening right now, think about projects you might tackle. I can definitely remember trying to hang this, like, ridiculously heavy antique mirror once.
Oh, boy.
Yeah, and I grabbed some brackets I thought looked sturdy, but honestly, looking back, knowing this now, they were probably light duty, maybe 22 gauge. Total mistake.
Yeah, that's a classic scenario.
Learned my lesson there. But if you're putting up, say, serious shelving in the garage for heavy tools, you'd absolutely want that heavy-duty, low-gauge bracket.
No question. 10 or 12 gauge, probably.
Or, flip side, if you're doing some kind of small metal art piece, you'd want that light-duty, higher-gauge stuff because it's easy to work with.
Perfect examples. It maps directly to the application.
So, connecting this to the sort of bigger picture, understanding gauge isn't just about getting the thickness right for strength, is it?
Not at all. It's really about optimization. You're balancing three critical things.
Yeah.
Strength, yes, but also the overall weight of the part or assembly, and definitely the cost.
Ah, weight and cost again.
Absolutely. Manufacturers like Dundee Manufacturing, who put out that guide, they live and breathe this stuff. Every decision they make when cutting, stamping, forming steel components, it's based on nailing that gauge selection.
So they get the performance needed without waste.
Exactly. It ensures their products, which they emphasize are USA made, deliver the required strength, but also stay cost effective. And things like fast shipping matter too, getting the right part quickly.
So let's bring it back to the person using these parts. What does this mean for your project's success and maybe your wallet?
Well, it means choosing the wrong gauge has real consequences. Go too thick.
Yeah.
You might be paying for steel you don't need. That adds unnecessary cost right there. Plus, it adds weight.
Which could matter for shipping or handling or even the thing it's attached to.
Right, it can cascade. But then the other side is worse. If you go too thin,
That's the failure risk.
that's the structural failure risk.
Right.
And that's obviously the outcome everyone wants to avoid, always.
Makes sense.
Which is why, good suppliers or manufacturers will often help. They might review your specs and say, hey, 14 gauge would work here just as well as 12 and save you some money. Or they might even suggest a slight redesign using a different gauge to optimize it.
That's good partnership.
It is. It's about getting the right solution.
Okay, so that really wraps up our deep dive then. The big takeaway seems to be steel gauge. Super important. The numbers work backwards. Higher number. Thinner steel. Got that.
The key flip.
The key flip. But beyond that, picking the right gauge is this balancing act, directly hitting the strength, the weight, and the cost of your project. Knowing this just helps you make smarter choices.
It really does. And maybe it leaves you with something to think about, too.
Oh.
Yeah, like the next time you see a metal object, it could be a simple pipe strap holding a pipe in your basement, could be a big bracket holding up something substantial, or even just a part on a machine.
Uh-huh.
Just take a second. Think about the unseen decision behind its thickness. What job is it doing? What forces is it handling? And how does its gauge, its thickness, reflect that specific purpose? It's kind of everywhere once you start looking.
That's a great point. You start seeing the engineering behind everyday things. Excellent thought to end on. Well, thank you for joining us on this deep dive into the surprisingly fascinating world of steel gauge.